friends. Today we shall discuss dielectrics and dielectric polarization, in which we study what is dielectrics, what is the difference between polar and non-polar molecules, and the effect of electric field on dielectrics and the effect of dielectrics on electric field. Dielectric polarization, dielectric breakdown and dielectric strength of dielectrics. First, dielectrics. The non-conducting materials like rubber, plastic, oxygen, hydrogen, nitrogen, HCl, NH3, pure water are called dielectrics. They do not conduct current at low values, and when dielectrics placed in electric field, they affect the electric field, and such materials are called dielectrics. Dielectrics are the non-conducting materials like HCl, ammonia, pure water, hydrogen, oxygen, plastic, rubber, and so on. They affect the electric field in which they are placed, and these dielectrics are made up of either polar molecules or non-polar molecules. Then what are the polar and non-polar molecules? A molecule in which consider a molecule consisting of two charges, negative charge, this is negative charge and it is positive charge, and these are the centers of negative and positive charges, and the region of negative charge is up to here and the region of positive charge here. Therefore, the clouds of negative and positive charges or the regions of negative and positive charges are overlap. Therefore, the common center for negative and positive lies in between them, and that we suppose that the negative charge and the positive charge are coincident. Positive and negative charges are coincident, and suppose this is the hydrogen molecule. It consists of two hydrogen atoms, and one is its charge is negative and it is positive, and the centers of positive and negative charges are coincident, and such molecules are called non-polar molecules. Therefore, the molecules in which the centers of negative and positive charges are coincident is called non-polar molecule. And for non-polar molecule, permanent dipole moment is equal to 0. Dipole moment P equal to 0, because we know that dipole moment P equal to Q into 2A, where 2A is the distance between positive and negative charges. Here the centers are coincided, therefore there is no distance between the centers of positive and negative charges, hence P equal to 0, that is dipole moment of non-polar molecules is equal to 0. Then what is polar molecule? A molecule in which the center of positive charge and the center of negative charge are well separated, or there is a certain distance between negative and positive charges. Consider HCl. This is chlorine and hydrogen. Here hydrogen donates one electron to the chlorine, hence chlorine becomes Cl negative and H positive, and there is a distance between negative and positive charges, and such molecules are called polar molecules. Therefore, a molecule in which the center of negative charge and the center of positive charge do not coincide is called polar molecule. For example, HCl, water, ammonia, etc. Clear? Therefore, a molecule in which the center of positive charge and the center of negative charge coincided is called non-polar molecule. For example, hydrogen, nitrogen, oxygen, etc. And the permanent dipole moment is equal to 0. And a molecule in which the center of positive charge and center of negative charge do not coincide is called polar molecule. And polar molecule, they possess permanent dipole moment. Here dipole moment P is not equal to 0. They possess a permanent dipole moment. Example, HCl, water, chlorine, ammonia, and etc. And the dielectrics which are made of non-polar molecules is called non-polar dielectrics, and a dielectrics made up of polar molecules is called polar dielectrics. Then what is the effect of electric field on dielectrics? Consider a non-polar dielectric slab, a slab consisting of non-polar molecules, and non-polar molecules are represented as plus minus, the centers are coincident, and polar molecules are represented as minus plus. There is a certain distance between positive and negative charges. Consider a non-polar dielectric slab consisting of non-polar molecules, and in the absence of electric field, when electric field is equal to 0, dipole moment is equal to 0. But when a non-polar dielectric slab is placed in an external electric field E, let E be the electric field in which a dielectric slab is placed, then what happens? The positive charges are attracted in the direction of electric field, external electric field, and the negative charges, they are attracted in opposite direction to the applied electric field, and as a result an opposite electric field is induced in the slab and is represented by EI. EI is the induced electric field when a non-polar dielectric slab is placed in an external electric field and opposite field is induced in it. Therefore the net electric field E net, applied electric field is E. It is the difference between E and EI, where EI is induced electric field and E is the applied electric field. Therefore net electric field decreases. Net electric field decreases. Therefore what is the effect on external electric field when a non-polar dielectric slab is placed in it? Net electric field decreases. Then what is the effect of external electric field on non-polar dielectrics? When a non-polar dielectrics is placed in an external electric field, positive charges are displaced in the direction of external electric field and the negative charges are displaced in opposite direction. Clear? Now, if a polar dielectric slab is placed, consider a polar dielectric slab. It consists of polar molecules. Polar molecules. And dipole moment of each polar molecule is not equal to 0. But the net dipole moment of all the polar molecules is equal to 0 due to their random orientation. That means the sum of all dipole moments is equal to 0 if in this direction is taken as positive, then it is negative, positive, negative. Therefore the sum of all the dipole moments is equal to 0, but dipole moment of each molecule is not equal to 0. And the dipole moment, net dipole moment of polar dielectrics is equal to 0 due to their random orientation. In the absence of external electric field, the polar molecules are randomly oriented in the slab. And when a polar dielectrics is placed in an external electric field E, now what happens? These polar molecules experience torque because these polar molecules are the dipoles, and we know that when a dipole is placed in an external electric field, it experiences torque, that is rotational effect. That means the positive charge is attracted in the direction of electric field and a negative charge in opposite direction, hence the dipole rotates. And the torque acts on these dipoles till all the polar molecules align in the direction of external electric field, or torque acts on these dipoles till the dipole moment acts in the direction of electric field. The direction of dipole moment, it is always from negative to positive, right? Then what is the effect of external electric field on polar molecules? When a polar dielectric is placed in an external electric field, the molecules experience torque till the dipole moment aligns along the direction of electric field. Then what is the effect of polar dielectrics on external electric field? If E is the external electric field, when the non-polar molecules align along the direction of electric field. The positive charge is stretched in the direction of field and negative charges in opposite direction. Therefore, an electric field is induced inside the slab and is represented by EI. And EI, that is induced electric field, is always less than applied electric field. Therefore, net electric field E net is equal to applied electric field minus induced electric field. Therefore, either non-polar dielectrics or polar dielectrics placed in an external electric field, they affect the external electric field. That means the net electric field decreases. This is the property of dielectrics. Therefore, when dielectrics are placed in an external electric field, they decrease the external electric field. This is the property of dielectrics, and this property it is used in capacitors. Clear up to here? Now, suppose if the external field increases, what happens? The positive charges are more attracted in the direction of electric field and negative charges in opposite direction. Therefore, the bonding between positive and negative charges becomes weaker and weaker as external field increases. And at a certain value of external electric field, E, the negative charges detached from the molecule and they induce on one side or in opposite side to the external electric field, and positive charges are induced in the direction of electric field, and this is called dielectric breakdown. This is called dielectric breakdown. And at this stage, an external electric field is induced in it such that net electric field E net is equal to E minus E naught, EI is equal to 0. Therefore, dielectrics behave as a conductor. In previous class, we have studied electrostatics of conductors. When conductors placed in an external electric field, what happens? Negative charges are aligned on one face and positive charges on the other face, and all other positive charges of nucleus and remaining electrons remain at the same positions. Therefore, an external electric field is induced in it. It is equal in magnitude and opposite in direction to the applied field. Hence, net electric field inside the conductor is equal to 0. And similarly, at a certain maximum value of external electric field, negative charges are detached from the molecule and they induce on one face, and the positive charges induce on the other face. As a result, an opposite electric field is induced. It is equal in magnitude and opposite in direction to the external electric field. Hence net electric field is equal to 0. Is equal to 0. Clear? Now one by one. What is the effect of electric field on dielectrics? When a non-polar dielectrics placed in external electric field, positive charges displaced in the direction of electric field and negative charges in opposite direction, and this we call as dielectric polarization. We call it as dielectric polarization, and during dielectric polarization the net electric field decreases and it is equal to applied electric field minus induced electric field. Similarly, when a polar dielectrics is placed in an external electric field, they experience torque, and the dipole moment, it experiences torque till the dipole moment aligns along the direction of electric field, and this we call as dielectric polarization. Dielectric polarization. And as external electric field is increased, negative charges detach from the molecule and they induce on one surface and positive charges on the other surface, and this is called as dielectric breakdown. Dielectric breakdown. Then what is dielectric strength? Dielectric strength, it is the maximum value of external electric field up to which a dielectric remain unbroken is called its dielectric strength. Or dielectric strength, it is the maximum value of applied electric field that a dielectric can tolerate without breakdown is called dielectric strength. And it is found that the dielectric polarization, it is represented by P vector, is directly proportional to applied electric field. As applied field increases, dielectric polarization also increases. As strength of electric field increases, the degree of polarization also increases. Hence, polarization factor P is directly proportional to external electric field, or polarization factor P is equal to chi E into E, where chi E, chi, chi E is proportionality constant called electric susceptibility, and this we study in magnetism and matter, that is magnetic susceptibility and electric susceptibility clearly in next topic. Clear? And also it is found that dielectric polarization P can be defined as, it is the ratio of net dipole moment. Net dipole moment, P is dipole moment, net dipole moment per unit volume. Per unit volume. That means if a polarized dielectric slab is cut into small volume elements dV, then net dipole moment of polarized dielectrics to per unit volume is called dielectric polarization. dielectric polarization is defined as it is net dipole moment per unit volume. Net dipole moment per unit volume. And also dielectric polarization is equal to P net, net dipole moment per unit dielectric constant, where K is dielectric constant, and you have studied in first chapter dielectric constant, and dielectric strength is different from dielectric constant. Clear? And here important questions are: what is dielectrics? Give an example for 2 marks, or give the differences between polar and non-polar molecules. For 1 marks, what is the effect of electric field on dielectrics? Or what is the effect of dielectrics on external electric field? What is dielectric polarization? Dielectric polarization can be defined as it is the net dipole moment per unit volume, or it is the net dipole moment per unit dielectric constant. Dielectric constant. Then what is dielectric breakdown? What is dielectric strength? Very important. What is dielectric strength? What is dielectric polarization? And for 2 marks, give the differences between polar and non-polar molecules. Thank you. All the best. We shall meet next class.